Let's take a look at the last question on the TLC, IR, and melting point lab. Was your separation of benzoic acid and 9-fluoronon successful? Explain using TLC, FTIR, and melting point data. So you have your results. Now it's time to interpret them. Hopefully this video can help you analyze these different characterization techniques and apply them to your own. So first, looking at TLC here, this is the example directly from the pre-lab. The spots are already labeled, so that's super helpful. But you can see for pure benzoic acid, there is one spot, while that's labeled by PB. And our product, which is labeled by B, has 2 spots here. So 1 and 2. Spots 1 and 2 on this TLC plate are relatively similar in size and position, so that's great. However, spot 3 from our product does not show up in the pure form of benzoic acid. So that indicates impurities in our product and an unsuccessful separation at this point. Moving on to FTIR here, this is an example, benzyl alcohol, very similar functional groups to benzoic acid, so you can easily apply to your FTIR spectrum of benzoic acid and even 9-fluoronon as well. So I have the structure drawn on the FTIR spectrum. Make sure you include that as well on yours. And the first functional group I notice here is our alcohol group, which moving over to the important IR peaks, I can see in the top row here with a stretch from 3650 to 3200 and a strong broad peak. So looking back at my spectrum, I can identify it right here. So that is our alcohol group. Another functional group I recognize is our benzene. We see this all the time. And it's right here in our table with a stretch from 2000 to 1650 and very, very distinct appearance as teeth and very weak. So looking at that between those wave numbers, I can see right here, that looks like our teeth. And again, very weak. So those are those functional groups there. Make sure you're comparing to the pure form of benzoic acid and 9-fluoronon when you look at your FTIRs as well. Finally, just for melting point, I want to emphasize the importance of finding out the melting point for pure benzoic acid and 9-fluoronon because it is very important to compare to the results you obtained in lab. And then if your melting points for these 2 compounds are a little bit higher or a little bit lower, what does that say about your product? Are there impurities? Did you make any errors in lab? These are important things to consider when writing that final paragraph. So hopefully this helps, and let your TA know if you have any questions.